Hey guys, this is me, Prince. Apparently, I've been working on Solana for like more than a year, 2 years now, and throughout my journey, I have learned a lot. Solana has given me a lot. I mean, I have a name and fame from Solana, so it's about damn time I start contributing something back to the ecosystem, right? So the first thing that came to my mind was to teach whatever you know, right? Whatever I have learned through this long journey of Solana, while building product in Solana, while working for companies that are existing, that got like acquired, even that got closed or like sunset on Solana. So a few things that I came to learn on this ecosystem. I really want to appreciate this ecosystem and give back something to the ecosystem. And on trying to contribute this back to the ecosystem, I was looking into uh, a backend roadmap video by I think the guy name is seriously, and the format there is I think the format here in our video or in our curriculum is straight up taken from the backend from first principle is the or one of the best structured curriculum I have ever seen on backend. So I think Solana deserves something similar, and uh, it is just a way to contribute back something to the ecosystem, trying to make something similar. So overall on Solana, there are basically three stuff which are going on, or apparently there are more. Overall, Solana is a huge scope, and so is the company on Solana. So is working on Solana. It's like wide scope. But whatever I through my journey, whatever I have worked on, that can be categorized into three basic stuff. So one of them was to write smart contract on Solana. So every Solana company that you see right now, like Jupiter or Camino or Pump.fun or any other Solana company that is earning millions and billions, they're working on some contract, right? They're working on some Solana program. So the very first part is to know or have a grasp the idea of how to write that smart contract. So this is the very first thing that we are going to do in this series. So the name of the series is going to be Solana from first principle, just like it's backend from first principle, and we are going to learn Solana from first principle just the way I did it. So uh, I have tried to divide it in three different categories. First one was to write smart contract. So this is the very first thing that we are going to do. We have already done Vault and Escrow. So these are the two smart contract that we have already done in this series. So you can find videos already. And the next thing that we are going to do is AMM. So I don't want to waste your time by exactly telling what exactly is a vault, what exactly is an escrow. We already have a video for that. So starting from AMM, AMM is basically stand for or automated market making. Yeah, it stand for automated market making. So if you look into any pool, the where you exchange stuff, like when you like let's say you have USDC and you want to buy bonk on Solana, so you go to an AMM. So all those Jupiter, all those Meteora, every pool that you see is some form of AMM only, whether it's CLMMM or other form of AMM, but it's an AMM, it's an automated market maker, and it does make it helps you to trade or exchange tokens. After that, you're gonna do a contract on NFT staking. So, but remember, every contract in each would be probably divided into 3 to 4 videos. First one will include architecture diagram of the contract, just like we had in the vault and escrow. After that, we'll have a coding where we'll code the where we'll probably not code, where we'll try to understand the code which I have already written, so that it won't waste your lot of time. And yeah, after that, the third video is going to be testing. So this is probably we're going to follow along the entire smart contract series. After that, we have fourth contract that we are going to do is probably NFT staking, where we'll learn how do we stake the NFT. So there are differences between staking an NFT and staking in Solana and other stuff. unstaking a meme coin or any other SPL tokens. So in some cases, apparently if you stake Sol, like if you do a native staking of Solana, it stays in your wallet, like you can check in your own wallet. Similarly, if you do NFT staking, it just the authority of that NFT just freezed or delegated to the contract, but NFT is still in your wallet. You can check it, you can see it. But and another type of staking is that where you basically transfer your funds to the vault of contract. So this is we are going to do. After that, the fifth contract that we're going to write is probably NFT marketplace, where we'll try to uh, create a marketplace where people can buy and sell NFT. They can list their NFT, they can unlist their NFT, and after that somebody can buy and sell it. After that, we're going to do is bonding curve. So this is the first contract that was like that I had to boggle my head around a lot. So apparently if you look into the most well known or most earned company on Solana, which is pump.fun, the core infrastructure or the core program that works behind that $1 million $1 billion company is this bonding curve, a simple contract or simple mathematical formula which governs the entire contract. After that, we're going to learn how to do a CPI. CPI stands for cross program invocation. So if you remember in good old days, like back when pump.fun started, whenever a token is graduated, it was like you could trade it on other platform like Raydium. It was migrated to Raydium. So what do you mean by migration? How is token able to migrate from pump.fun to Raydium? So we are going to learn how do we CPI into another program, how do we CPI into program that already exists on Solana chain like Raydium, Jupiter, through our program. So we'll be able to do some stuff just like pump.fun. We'll be able to migrate our token from our bonding curve to Raydium or Jupiter, other any program which is there on Solana. After that, we'll try to learn about Pyth integration. So this is the way to basically get price of token on chain. It's a way somehow, like for example, if you look into any borrow lending platform, uh, like Camino, or I think Drift is also one, or Jupiter Lend. So these all platform does what they all give you facility to either borrow or lend your asset. So when you are doing that, when you borrow something from Jupiter, when you lend something to Camino, they the contract is supposed to know the current price of that asset, so that they can calculate your exact health ratio required for borrowing lending. So for that we need to integrate Pyth to the chain. So we're going to learn that. After that, we'll try to write a contract on algorithmic stablecoin. So if you like, you already know, right, what is a stablecoin? Stablecoin is like that is backed by uh, US dollars, like USDC, or uh, like any other, like USDC is a stablecoin, USDT is a stablecoin, and there are also that are quite famous in the ecosystem right now. But algorithmic stablecoin is something different, right? In this, apparently all the calculation of this asset which backs of the stablecoin is a mathematical formula. Like we can use Solana as an asset which will provide as a backed value for our stablecoin. So in this contract we'll write some mathematical formula or a type of instruction where um, every people who stake some Sol will get to mint some stable coin, and there will be an health ratio where it depends on how much Solana he has staked and what is the current price of Solana. So if he had staked some, let's say if he had staked some $100 of Solana, and we let him mint, like our, let's say our health ratio is very uh, strict. Let's say our health ratio is twice, and then we are giving him only 0.5%, or let's say only 50% of stable coin. So he's able to take $50 of stable coin, but let's say the price of Solana crashes down to $60 or for $50, then his health ratio is in danger, right? So anyone can call contract and liquidate his position. So we are going to learn something like that in the algorithmic stablecoin contract. After that, we're gonna do is DBC, which basically stands for dynamic bonding curve. So there is slight difference between a normal bonding curve and a dynamic bonding curve. So in a normal bonding curve, the parameters are fixed, right? So you know at what point the token is going to graduate, you exactly know what would be the starting price of the token, so everything is fixed. But in a dynamic bonding curve, you're given authority, or you're given an option to choose everything. Like you can choose at what price your token is supposed to graduate. And recently it was quite famous, and all the big big platform, I think Meteora or Raydium, I'm not sure about the Jupiter, but all of them integrated DBC into their platform, and it was quite famous. It helped many industry or many product on Solana to launch their token according to their own way. Like it was not just on pump, go there and launch like any random people, but you can customize your token to raise money or whatever. After that, the 11th contract, DAO voting. It's a contract where decisions are made. So let's say Solana is a decentralized autonomous organization. So where I want to uh, add a feature, right? We want to add a feature on Solana, and so the people who are staked on Solana, they can vote if that feature should be added or not. After that, we'll try to uh, integrate token 2022 supports for all of them, and apparently there would be more smart contract. These are the basic smart contract that I have done throughout my journey, and there are also complex smart contract, like uh, making an entire marketplace on a bonding curve, and etc etc. We'll try to add it to the series if required. After that, the second type of job or work that exists on Solana is basically data indexing. So Solana is a huge blockchain, right? It has like millions and billions of user data available there. So every company needs to index those data or get those data so that they can provide it to the user on their front end. So we'll learn how to index and get those data, right? First, we'll try to do that in TypeScript and Rust by using simple RPC. And after, like, once your companies grow, in the beginning, let's say you have only 10, 12 or 15, you're on a working stage, you're making an MVP, then at that point you can even use RPC as an indexer to get data, like Helios or Yellowstone, whatever RPC you want to use. After that, once your product grows a lot, you have lots of user on your platform, that RPC fails, right? RPC is not able to take all the data, it start to miss transaction, it starts to it gets slow eventually. Then after that, there is this thing called gRPC that you use basically to get data faster and more efficiently. You don't miss a lot of data. After that, in gRPC, so in gRPC there is a problem that uh, data transfer happens in form of bytes. So you'll have to do uh, serialization and deserialization of data on your own end in order to get that data. So uh, we will learn how to serialize and deserialize data by using raw Rust. After that, when you go one step further, all the companies all the companies that provides their own gRPC, they also gives you their own protobuf that you can use to deserialize their like deserialize the data. Let's say I want to deserialize the data of any famous platform like Camino or Jupiter. So they do have their protobuf, which you can use directly with gRPC to deserialize the data. So we will try to learn how to use that. After that, the very fastest, like one if we go one step ahead than gRPC, then there is a thing called Shredder, which basically uh, is more faster than gRPC to index data. So it's like a little bit complicated. Apparently Solana, um, like the leader node built built the block, and it divides blocks in different threads, and it transfers this thread to the through turbine. And we'll try to and what exactly happens, the shredder technology is something, they throw the entire threads at you and you try to deserialize that threads, you try to get data from that threads. So we'll try to use that to index blockchain data. After that, there is one thing called unthread. This is also quite unique, and I don't think some a lot of people use it. So in this, what exactly we do, we try to take raw threads from uh, leader node or any node, and we try to build a block on our own platform, on our own end, and then we try to deserialize data from it. This is quite interesting. We'll try to go through all of that, and after that, the third, or maybe not the last, but I have seen what exactly works in Solana are bots. So I have been asked a lot, like I've worked on making sniper bots, making arbitrage bots, making trading bots and all. So we'll try to also learn how to make a simple trading bot where you can buy and sell any tokens on any platform like Jupiter, Raydium, or even pump.fun. After that, we'll try to make a sniper bot, and we'll try to go one step further. We'll try to make sniper bots with multiple ingester. So what exactly happens is, why multiple ingester, right? So what exactly happens is, when you try to ingest using a single gRPC or single source, sometimes it gets slow, sometimes it's get fast. You cannot exactly trust or on the reliability of the source, right? So what exactly we do, we try to ingest using multiple sources at once, and whatever is the fastest, we consider that, and we'll try to execute our trade. So sniper bot should be fastest, right? Once I tried to like make a sniper bot which was sniping tokens in same slot. Like if the token is created in X slot, we were able to snipe the token in the same slot, not even one slot further or two slot further, in the same slot. And if you know, Solana slots are just 400 milliseconds, and even that somebody was able to like execute the trade before us. So we'll try to learn what exactly is happening here. After that, uh, we'll try to go through arbitrage bots. So what exactly is an arbitrage bot? So arbitrage is an opportunity where, so here will the knowledge of will be quite handy while making an arbitrage bot. Consider a pool of Solana and USDC, right? Let's say you want to trade Solana and USDC on Jupiter, and same you want to trade Solana and USDC on Camino. So there are two separate pools, right? And let's say uh, X whale, right? A very big user comes to Jupiter platform. Let's say he sells, let's say 100K worth of Solana. So in that pool, there are like huge number of Solana, and USDC is less, right? So according to the calculations, the price of Solana will probably decrease in this pool, but in the other pool, the price of Solana would be same. So you can buy Solana cheaper from here and sell it to other platform. So this is something called arbitrage, and these are done by basically very fast bots. They execute the transaction in milliseconds, like less than a milliseconds, and then they try to keep the pools synchronized, or like they keep the Solana in fix, and then they try to earn some revenue on it. We'll try to learn how to build that arbitrage bot, and I think this should be more than enough to give you a basic starting point of Solana, and you can like grow your career from here in Solana. So yeah, let's get on it. And before we get into I would like to tell you that we already have the videos out for Vault in Escrow. I'll try to make it more uh, like structured. I'll try to put everything into a single series, and I'll try to number them accordingly so that it would be easier for you to like follow through. Let's get on it.